Okay, for example 2 on constant acceleration, we are looking at a ball thrown vertically upwards from a platform 16 metres above the ground. If it has an initial velocity of 24.5 metres per second, find the maximum height above the platform the ball reaches, the time taken for the ball to reach the maximum height, the time taken for the ball to reach the ground, and the speed of the ball when it hits the ground. So to start this question, I want to start with a really simple diagram. We've got a platform and we've got the ground. This is 16 metres high, and we're going to throw the ball directly up, and then that ball is going to hit a maximum height and then go all the way down to hit the ground and bounce off who knows where. So I know initially the velocity is 24 metres per second, so I've got when t equals 0, v equals 24.5, and x equals 16. So if I've got this 24.5 and 16, what I'm assuming is that this direction up, where I throw the ball first, is the positive direction. And very simply then, that means down is the negative direction. And when I throw a ball, the only acceleration on this object is going to be gravity's pushing that ball back down, and that gravity is going to be pushing the ball down, so I can say that A in this case is equal to negative 9.8 metres per second squared. So we have our initial acceleration. As mentioned, I can use the constant acceleration formulas that we've seen in physics, but we're trying to use a integral approach here, or a differential equation approach here, so I'm going to work with that differential equation approach. Now if I want to find the maximum height, that'll be when the velocity equals 0. So let's start with our acceleration equation. A of t equals negative 9.8, and I can find a velocity equation by finding the integral of negative 9.8 with respect to t, and I want to work out the equation here, so I'm going to find out what t is. So my variable is t, and I know my initial t value is 0, and the initial velocity is 24.5. So if I integrate, I get negative 9.8 t from t to 0 plus 24.5, which then gives me negative 9.8 t plus 24.5. And it makes sense that we go from a linear, from a constant. When we anti-differentiate it, we get a linear equation. So this is v of t. Now I wanted to find out the maximum height. So at this point up here, at the maximum, my velocity at that stage, it's not going up, it's not going down. My velocity is instantaneously equal to 0. So to find the maximum height, or to find the time when I get a maximum height, I can solve this expression. Which equals 9.8 t 24.5, t equals 24.5 on 9.8, and trying to avoid using my calculator here, I got 245 on 98. Can I simplify that expression? I know it's got to end in a 5, can't end in a 3, so I don't think I can simplify that. I'm going to leave it exactly like 245 on 98. And then I'm going to cheat and I'm going to break out a calculator and quickly work out what that is as a decimal. So 245 divided by 98 is equal to t equals 2.5 seconds. So we get a maximum height at 2.5 seconds. So we've actually answered part B before we've answered part A. Now what we've got to do is work out what the height is. And in order to do that, we need an expression for x of t. And to get that expression, we need to know what the antiderivative of negative 9.8t plus 24.5 is with respect to t. And we want to find out what the height is at 2.5. And we know when time is 0, the height is initially 16. Okay, this is going to be interesting without a calculator, so I'm going to have negative 4.9 t squared plus 24.5 t plus 16. And I want to go from 2.5 to 0. And now when I substitute in 2.5, that will give me my value, minus when I substitute in 0, it'll just give me 0, plus 16. So my next line now will be 2.5 squared is 625, so it is minus 4.9 times 6.25 plus 24.5 times 2.25. I don't like that. 24.5 times 2 is 49. Half of 24 is 12.25, so it's 49, and 12.25 is 61.25 plus 16. And then I need to do 4.9 times 6.25, so 4.9 times 6.25. Oh, wow, this is testing my quick maths. Let's go, I'll do it the long way. 9 times 5 is 45, carry the 4, 9 times 2 is 18, 4 is 2, carry the 2, 9 is 54, 56, put down the 0, 4 and 5 is 20, 8, 8 plus 1's got to be 0, carry the 1, and 4 times 6 is 24, so it's 25, add them to go 52603, and we need 3 decimal places, so it's 30.625. Negative 30.625 plus 61.25 plus 16, which is minus 14.625 plus 61.25, and then take that away. 14.625, 4, 0, 10, 5, 2, 0, 6, 5, 10, 6, 4, which is 46.625 meters above the ground. So the maximum height equals 46.625 meters above the ground. And we got some fun maths there without a calculator. obviously you would probably go straight back up to this step here, and you would type that directly into your CAS to get an answer in one step. Okay, part C, the time taken for the ball to reach the ground. So we want to find out when the height is 0. So find when h, not h, well, it is h I guess, but in our case we're talking about displacement. We want to know when displacement is equal to 0. Alright, so now we're going to have to do my x of t again, and I know this time I want to find out what t is, and I know initially that negative 9.8t plus 24.5 dt is equal to 16. Alright, I'm going to cheat this time. I'm going to the calculator. Once by hand is enough. So on my calculator, I need to use calculus. I'm using an integral. Oh, couldn't see it. There it is right in front of me. Got 0 down the bottom. I'm going to use t up the top, and I have negative 9.8 t plus 24.5 dt, and on the end I've got a plus 16, and enter. So there's my equation for the displacement, and I want to take that. Actually, before I do that, what I want to do is I want to now use algebra and solve this equation here equal to 0, and I want to find out what t is. So t equals negative 0.5. Obviously it's not negative 0.5 because we can't go back in time, so my answer has to be t equals 5.584. So t equals 5.584. So on CAS, t equals 5.584. Nice. And final thing, the speed of the ball when it hits the ground. Okay, so the speed of the ball is the velocity, and I don't need to worry about whether it's positive and negative because speed's a magnitude of velocity. So here's my equation now for the velocity. I can substitute that value directly. Actually, that wasn't my equation. Undo that. Here's my equation for velocity. We can substitute that t value directly into that equation. So part D, velocity is equal to negative 9.8 t plus 24.5, and we want to know what it is at 5.584. So it's negative 9.8 times 5.584 plus 24.5. And when I do that, same thing again. I don't like these numbers by hand, so I want negative 9.8 times the answer that I got before. But I want to get rid of all of that. I get rid of that equals sign too. Plus 24.5, so I'm using my calculator to keep the exact values, and I'm approximately negative 30.23 meters per second. Negative 30.23 meters per second. So V equals negative 30.23 meters per second, and because it was speed, I don't care that it's negative, so I actually need to make sure I convert that to a positive answer. And that's the end of the problem.